So I want to solve x squared minus 10x plus 7, and it says it wants me to use completing the square. So I can see I have x squared minus 10x plus 7 equals 0. So what I'm going to do is x squared, and I'm going to write this as plus 2 times negative 5x. And then I'm going to leave a little bit of space. And I guess I could go ahead and subtract that 7 over to the other side. Okay. And so what is it that I want to add here to both sides that will make this a perfect square? Well, the thing I want to add here is plus negative 5 squared, and I'm going to add that to both sides. And so what is negative 5 squared? That's 25. And so I can rewrite this as x minus 5 quantity squared, and then I'll have negative 7 plus 25. So when I do 25 minus 7, I get 18. And then I can take the square root of both sides. And so I have x minus 5 is equal to plus or minus the square root of 18, and add the 5 over. So those are my two solutions, 5 plus square root of 18 and 5 minus square root of 18 on number 21. The next problem, I have 3x squared minus 15x plus 6 equals 0. So I'm going to start by pulling a 3 out of the first two terms. And I'll go ahead and subtract the 6 over to the other side. And so to make this a little bit more clear, I'll do 3x squared plus 2 times negative 5 halves x. And then what do I need to add inside here to make this a perfect square? Well, what I need to add here is going to be a plus negative 5 over 2 quantity squared. But did I really just add a negative 5 over 2 quantity squared? Well, I really added 3 times that, right? Because there's a 3 multiplied by everything inside those parentheses. So when I add it over to the other side, I'm going to say plus 3 times negative 5 over 2 squared. And then I can rewrite this inside part as a perfect square. So I'll have 3 times x minus 5 halves squared is equal to and what's this side? So that's going to be negative 6 plus 5 squared is 25 times 3 is 75. 2 squared is 4, so 75 fourths. So negative 6 plus 75 fourths is equal to 51 fourths. And then I'm going to divide by 3. So 51 twelfths is equal to x minus 5 halves squared. Then I could square root both sides. I'll get x minus 5 halves is equal to plus or minus square root of 51 twelfths. And then I can add the 5 halves over. And so those are your two answers. X plus, or 5 halves plus 51 twelfths, and 5 halves minus 51 twelfths. Okay. And on number 23, it says that I want to solve this by factoring and then using the zero product property. So to do that, on number 23, I'm going to start by adding that 24 over to this side. So I'll have x squared plus 11x plus 24 equals 0. And then I want to try to factor that. So I want to think I'll have x's here, and then I want the things that go here and here to be numbers that will multiply to give me 24 and will add to give me 11. So one thing you might notice is 24 is divisible by 6 4 times. That won't work. It's divisible by 12. 12 2 times. Can't get 11 out of that. It's divisible by 3 8 times. 3 times 8 is 24. I think that's going to give us the 11 that we need. So if we do 3 and 8, I can do 8x and 3x will add to give me that 11x. So those are the numbers that I was needing. And so the zero product property says that if I have two things multiplied together, this thing and this thing, equal to 0, the only way that can happen in the real numbers is if one of those two things were equal to 0. So I either have x plus 3 equals 0, or I have x plus 8 equals 0. Well, in this first case, I have x equal -3, and in the second case, I get x equal -8. So those are my two solutions. So for the next problem, problem 24, it says to solve this using the quadratic formula. So the quadratic formula is a way to solve quadratic equations of the form ax squared plus bx plus c equals 0, where the a is the coefficient of the x squared term, the b is the coefficient of the x term, and the c is the constant term. And when I solve that, I get x equal -b plus or minus the square root of b squared minus 4ac all over 2a. So that's what the quadratic formula is. It gives us a way to solve for x for any quadratic equation that we have. And so if I want to do this, I can see that this 3 is my a, the -5 is my b, and this -6 is my c. So I get x equal negative of -5, which is +5, plus or minus the square root of -5 squared minus 4 times 3 times -6, all over 2 times 3. So that gives us x equal 5 plus or minus the square root of 25 minus 4 times 3 times 6. Oh, 25 plus, sorry, the minus and the minus will make a plus there. So that's 97 all over 6. And it doesn't look like that's going to reduce anymore because 97 is not a perfect square. So I think that's it. On 25, it says to use the discriminant to determine the number and type of solution. So I think this here should be a b squared, not a subscript, b squared minus 4ac, to determine the number and type of solutions. And so if I look at this here, that b squared minus 4ac, that's the underneath the square root part of the quadratic formula. So if I look at b squared minus 4ac, b squared minus 4ac is equal to 2 squared minus 4 times 5 times -3. And if I look at that, I get plus, so I get 64 for that. And that is a positive number. And so since it's underneath that square root, that's going to give us a positive underneath that square root. So we will have real solutions. And because there's something under that square root, I'll have the plus and minus. So I'll get 2 real solutions. Okay. So this next one says solve this function for r, and I think it should be pi r squared plus pi r s, and I want to solve that for r. And so when I do that, I'm going to use the quadratic formula. It says here is kind of the hint, and so let me erase this part, and we'll use that quadratic formula. So, so I can move that a over to the other side, and I get pi r squared plus pi r s plus, minus a is equal to 0. Now I can use the quadratic formula. So my pi is my coefficient of the r, And then pi s is the coefficient b, and then the a is c. So a, these two things together are b, and this is c. And so if I use the quadratic formula here, I'll have r is equal to negative pi s plus or minus the square root of pi s squared minus 4 times pi times negative a all over 2 pi. And so I'm just going to leave it like that. There's my solution of r. Okay, number 27 says that Lorene is making several open-topped boxes to carry plants. She makes them from rectangular sheets of cardboard. The length of the original piece of cardboard is 12 inches more than the width. And the volume of the box is that. I want to determine the dimensions of the original piece of cardboard. And so I know the volume of my box is going to be the length times the width times the height. And if I think about the length and width and height, the length and width are going to be this right here on these fold lines. So this is my length, this is my width, and my height is going to be 6 inches because I'm folding up on that 6 inches. So so the height again is going to be 6. The width is going to be x, and you're subtracting 6 here and here. So the width here is x minus 12. Okay, and then the length is going to be, well, I know that this total distance is x plus 12, but then I'm subtracting off 6 here and subtracting off 6 here. So the length is actually going to be x plus 12 minus 6, so it's just going to be x. And I know the length times width times height is my volume, and that's equal to the volume, which is 1,728. And so if I multiply this all out, I'm going to get that 1,728 is equal to 6x squared. And then the x and the 6 both multiply by that negative 12. So I'm going to get minus 72x. So what I'm doing is I'm distributing this x across these two, and I'm also distributing that 6 across these two. And so the x times 6 is the 6x squared. The x times negative 12 times 6 is the negative 72. I can see that's a quadratic equation. And so I'm going to write it all out here. So I get 6x squared minus 72x minus 1,728 equals 0. I can use the quadratic formula there. Unless, is everything divisible by 6? Yeah. Yeah. So I'll get, if I divide everything by 6, I get x squared minus 12x minus 288 equals 0. So I need factors of 288. It looks like 288 is 12 times 24. So I can actually factor this. X minus 24, x plus 12. If you couldn't think of how to factor that, that's okay. You can use the quadratic formula and you'll get the same thing. So I'll get x is equal to positive 24 or x is equal to negative 12. Now, the x is a length there, so the negative 12 answer doesn't make sense in this context. So it looks like the x was 24, and then so that's the width of that original piece of cardboard. And then, so then the length of the original piece of cardboard was 24 plus 12. So x plus 12 is 36. So the dimensions of the original piece of cardboard are 24 by 36. Number 28 says this NBA basketball legend, Michael Jordan, had a 48-inch vertical leap. Suppose that he jumped from ground level with an initial velocity of 16 feet per second. using that thing, I want to write a model to express Michael's height in feet above the ground t seconds after leaving the ground. And so since everything is in feet and seconds, I'm going to use this to estimate my gravity instead of the other, because we're not dealing in meters and things. So we'll use that one. If the units that we were given were in meters, then I would use the other one. So I have S equals 1/2, and then I'll do 32 t squared plus, his initial velocity is 16, and then his initial position is 0. So this means initial velocity, and this means initial position. So the velocity at time 0 is 16. The position at time 0 is 0 because he's on the ground level. So this is our function here. We'll have S is equal to 32 divided by 2 is 16 t squared plus 16. Then use the model to determine how long it would take Michael to reach his maximum height of 48 inches. So that 48 inches is the S there. So we could do 48 is equal to 16 t squared plus 16, and I can solve that for t squared. So I subtract 16 from both sides. I divide by 16. And I take the square root. And again, I could do a plus or minus here, but since I'm talking about time, I'm going to pick the positive value, which square root of 2 is approximately 1.41 seconds. The next one says a patio is configured from a rectangle with 2 right triangles of equal size attached to the 2 ends. The length of the rectangle is 20 feet, and the base of the right triangle is 3 feet less than the height of the triangle. If the total area of the patio is 348 square feet, determine the base and height of the triangular portions. Answer with complete sentence and show all work. And so one thing that I'm noticing right away is that this triangle right here could fit over here in this place, and then it would make a rectangle. And so if I do that, I have a rectangle that is of dimension x by 20 plus x minus 3. And so 20 plus x minus 3 is x plus 17. And so I know my area is going to be the length times width. So x times x plus 17. And that's going to be equal to, what did it tell me the area was? The area was 348. So I'll get 348 is equal to x squared plus 17x. So I can subtract that over. And then I can use the quadratic equation to find solutions to that. So I'm going to go over here. So x equals negative 17 plus or minus the square root of 17 squared minus 4 times 1 times negative 348 all over 2 times 1. So let's see what's underneath that square root. So if we do 17 squared plus 4 times 348, that's 1,681. Let's see if that's a perfect square. I think it is. Square root of 1,681 is 41. So x equals negative 17 plus or minus 41 over 2. And so I can see that if I use the minus sign, that's going to give me a negative value for x, which wouldn't make sense. So I'm going to use the plus sign. Negative 17 plus 48 is 31 divided by 2, which is 15.5. So I'm throwing out the one that uses a negative sign because I know x needs to be a positive distance. And so determine the base and height of the triangular portion. So the height, so this is the height of the triangular portion. And the base of that triangular portion is that minus 3, which is 12.5. This is the base of the triangular portion. And again, the units of these are feet, so I can squeeze a little feet in here, feet. And this is 12.5 feet. So all of that is measured in feet.